Zoop. All right, so let's get back to it. Let's talk about problem number 3. So what's nice about problem 3? Do you remember? Correct. It's in y equals mx plus b. So real quick, let's talk about Mr. Red up there on top. Where do we start graphing Mr. Red? At up to. Very good. Remember, up to, your first word should always be either up or down when we're doing a slope-intercept line. So in this case, it's up to. And what's his slope? Up one, right one, just like that, or down one, left one. And remember, if you don't want to do every point, you can skip a bunch. Going down 5 and back to the left 5 would, of course, accomplish the same slope objective, right? So you can graph the line right now, or you can wait. I'm just going to go and head on down to Mr. Purple. And so how do we graph the Mr. Purple? You guys need me to pause this while you grab some rulers? Hold on a second here. All right. All right, we're back. So how do we start graphing Mr. Purple?
Down to.
Perfectly spoken. Down to. And what is the slope of that line?
Down 1, right 3.
Yes, couldn't have said it better myself. Down 1 and to the right 3 is perfect, as is up 1 and back to the left 3. Those will accomplish the same objective. All right, so we're going to graph our purple line, which will go something like this. And then we're going to graph our red line, which will go something like this. And we're still trying to be proper about this. So, I mean, they're just habits. So try to keep your good habits, put arrows on your lines. I can never stress that enough. And then what are we looking for? What's the end game here? Where they cross, which I think is pretty clearly right there where I circled in green. What is the name of that point?
-3, -1.
So our answer is -3, -1, right? That's what we're doing here, is we're finding the crossing point of two lines. Let's head across over to number 4. And again, I'll just color code them for you. How do we start graphing Mr. Red?
Down 1.
Correct. And what's his slope?
Up
Down
right
3,
2.
left, right 2.
I'm going to go up 3. And I don't disagree. I don't know if you heard Keith, but he said to go down 3 and left 2. And I don't have any issues with that because it's going to be positive, and that's what I'm going for here. Ratio of 3 to 2. I'm also going to go back up 3, 1, 2, 3, and to the right 2. And I do have enough room to do that one more time. So I'm going to milk it for all it's worth. And then as far as the purple line is concerned, what kind of line is that? Yeah, I mean, we should know that by now, huh? Right? But it's not a perfect world, so we might be a little bit off sometimes. But when it says x equals, it's vertical. So I'm going to start with Mr. Red. Graph a line that goes through those points like that. Okay, stick some arrows on it before I forget. And then I'm going to go to x equals -2, which is right here. Stick some arrows on there like that. And now the only task that's left is to observe where they cross. And that is, what's his name?
Negative.
Perfect. -2, -4. Did you have any questions on those first 4? We did the first 2 Thursday and the last 2 just now. What changes when we get to the back? You remember? Why is it harder? Yeah, so we add a layer of difficulty here because now we're the ones that have to do the prep work to get it ready. So tell me about this red equation. What would be a slick move here? You could move the 1. I'm going to move the y. Why would I do that?
Oh, to change the sign.
Yeah, because if it's -y, I'm like, hang on a second. Not only can I get you over there on your own side,
And then 0 is not.
but I can make you positive. So I just write positive y equals +1. And that equation is now ready for graphage. Rad. I'm going to get all the algebra done while we're here. Okay, let's talk about the purple equation. How do we graph or manipulate the purple one?
Put the 16 on the other side.
Flip the y in the 16.
I'm just going to go with, it's not what I would have done, but I don't want to be like controlling about this. So I'm okay if you just leave the -4y where he is, but then you do have to boot the 16. So we get the -5x to just stay, and the 16 changes to a plus. So we're closer now to our objective of getting y by itself. What do we have to do now? divide by -4. And we divide in all three locations. Remember, everybody gets divided. Division is distributive, just like multiplication is. And so we get y equals what? Oh boy, what's the slope?
4.
5/4 is the slope. So we have 5/4 of x minus, because it's a positive divided by a negative, and 16 divided by 4 is 4. Huge. So much more difficult than the front page because we got all that algebra to do. So talk me through this. How do I graph the red line?
Okay, you're gonna go down 4.
Red line.
I'm gonna go up 1.
I'm going to go up 1, and then what am I going to do?
Make a
I'm
horizontal
going to
line.
make a horizontal line because I know that when it just says y, it's one of those. Good job. How about the purple guy? Where are we going to begin that guy?
Down 4.
And then what's his like slopey dopey?
5.
Perfect. 1, 2, 3, 4, 5. 1, 2, 3, 4. And that's all the room we have for that line is just enough to make those 2 dots. So we're going to make a line through those points. Put arrows on both ends, and then we're going to finish the problem. What's the name of the point where they cross? So we write down 4, 1, and we're on to the next one. Questions so far? Ah, sweet. They're not going to get any more difficult. I mean, if you fundamentally know how to get y by itself and graph a line, I pretty much can't stump you anymore. Like you either get it or you don't. So let's start with the top one, Mr. Red. What's the best thing to do here? I don't want to. That'll make him negative. So sorry, I'm going to put my foot down on that
Move
one.
between x and y.
How about these things I'm pointing at with the arrows? Do you see them?
Yes.
Can you agree that you don't want them on the same side as y? Then let's relocate them both. I understand it's more palatable to just move one thing, but honestly, it's worth it to me to just leave that positive y right where he is and move the other guys, and then we're done. What does x become if we move him? What does
X.
+3 become?
-3.
That equation is now ready for graphing. Okay. Now I'm going to head down here to the purple one. And again, I'm going to tell you how. I'm not going to ask you this time. I'm going to tell you. Well, actually, I'll ask you. And if you don't say what I want you to, then I'm going to be bossy. What is the best way to solve this equation?
Move the y.
So, yes, here's what I'm going to do. Yes, thank you for saying the word swap. Do you guys see the two things? The green circle and the green rectangle?
Yep.
Switch them. If you take the green circle to the left, it becomes positive y. If you take the green rectangle and move it to the right, it becomes -7x + 3, and you're done. What would have been another good answer for the question of what should we do?
Couldn't you just keep it?
You could have just divided the whole equation by -1. You could have left everyone right where they were at the beginning and just divide here by -1 and divide here by -1 and divide here by -1. And that would give you the same answer.
Too much.
Yeah, it's up to you. I like just juggling things around. It makes algebra so much easier. Any questions on how we did the math? Okay, now it's time to graph. How do we graph Mr. Red?
Down,
What's his slope?
down, up, up, 1, 1.
I'll take up and left. I'll also take down and right. So there's going to be what our red line looks like. Perfect. Let's do the purple one. Where do we start the journey?
Up 3.
What's his slope?
Down 7.
That is a steep, steep line, right? We're dropping 7 altitude for every 1 unit of horizontal. So we're going to go down 1, 2, 3, 4, 5, 6, 7, right 1. And you can already see the point of intersection here, right? So there is the purple. And here comes the red. And then we're going to circle the point where they cross and name it. And that point is right there. What's his name?
1.
So we write down 1, -4. The only way really for this to be a difficult assignment is if you're struggling with something from the past, because the past taught us how to get y by itself and how to graph lines. We're just doing it twice in each problem. So if this is a difficult assignment, it's not because what I'm teaching you is difficult. It's because unit 3 might not have gone so well. So let's talk top, bottom. Red guy first. What do we do?
But swap the new. New with the one, new with the eight.
That took a while, but you know what? I see that. That's okay, though. I'm going to leave the 2y where he is. I'm going to leave the negative 3x where he is, and I'm going to bring that dumb 8 across and call it a minus. And then what do we do? Everything by 2. So we divide, 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 giving us y equals what? Just like that. So that one is ready for graphatology. And now we're on to the second one. And this is exactly kind of the same conversation as before. I feel like switching everything and then dividing might actually feel like a waste of time. So because I can't just move the y and call it done, I am going to go ahead and divide everything here by negative 2. Got it? What's my final answer going to say? Y equals what? Mm-mm.
Negative 3 over 2x.
It's a positive divided by a negative up there, right? So minus 4. You good? Okay. So what do you notice? It is. So in a case like this, you only have to graph it once unless you're feeling crazy. But if you just graph it once, go down 4. And then the slope is negative 3/2. You don't have enough room to go down and right, but you can go up and left. And that's all the room you have. And just graphing it once would be just fine.
And then it's like infinite solutions.
It is very good, just like we learned last week. And because we really just graph the same line on top of itself, instead of graphing it twice, just graph it once, and then you just write the answer. And the answer is that, how did we phrase it in our notes? I believe we called it infinitely many solutions. Does that sound about right? Okay. Remember, it does not mean that every number in the world is a solution. It just means that there are infinitely many numbers that do work. So that is that. All right, so that's the notes that we were unable to finish time-wise on Thursday. They are now officially done. I'm going to come around and hand out assignment number 26, and that's what you're going to do today. I'll keep the recording paused in case you want to go over anything.